Alright, so I did renal, or more specifically, bilateral renal cell carcinoma. Um, so essentially, it's just a kidney cancer that happens in both kidneys, not just one. And that's what makes it so unique, and that's quite literally the reason I decided to pick this disease. Saw it in clinic about 2 or 3 weeks ago come about. And I'll kind of get into a few more details regarding that and how I kind of connected it here. Um, but it's just much more complicated because our kidneys are really important in filtering blood, obviously, and many other reasons like balancing electrolytes, helping control blood pressure, removing waste. Um, so when both kidneys are at risk because of tumors, we especially have to be careful and not only just helping the patient get back to normal, but in how we treat it because we want to make them as functionally possible, and our kidneys just don't regenerate like many other organs do in our body. So kind of get into what is an overall renal cell carcinoma and why is bilateral so rare and um, I guess you could say a little bit scary, a little more interesting and whatnot. So for the overview, renal cell carcinoma, like I said, malignant tumor from renal tubulary epithelial cells. I kind of get more specifically what area that is usually occurring and what people are usually more at risk for other than genetic risk. Um, so renal cell carcinoma accounts for 90% of renal malignancies, but bilateral renal cell carcinoma is really extremely rare to the point that it is 1 to 5% of those cases. I believe the last number I saw when I looked up on open evidence was on the last time they surveyed, it was like around 80,000 cases in America in a year for renal cell carcinoma, but bilateral renal cell carcinoma, I believe it made up of it was like 2 point something percent of those cases. So you're talking less than 1,000. Um, so moving on from that, sometimes both tumors appear at the same time. This is called synchronous. But sometimes one appears and then the other shows up months, years down the line, and that would be called metachronous. Yeah, sorry, words are hard sometimes. Um, so kind of adding on to the point earlier that it's just much scarier that not only are we worried about protecting one kidney and we know that the other one's functioning fine, but if one if that's happening at the same time, it's a little bit even more complicated in terms of how we treat it and how crucial it is to treat in a timely manner. Um, or if they occur at different times, how can we balance? How can we treat one while we just make the other one functional? How can we make sure both are at a functioning rate that one's not compensating too much for the other if we don't have to? Kind of like, I guess you could think of it kind of like an analogy, like you think about something has two filters. If one messes up and the other can compensate fine as long as we're tending to that one and monitoring that one. But if both mess up, we're trying to figure out what's the best way to do this. So do we make sure that they both function at a low rate? If one completely breaks down, I mean, one's doing a lot worse than the other. Do we just salvage the good one? And how so essentially that treatment plan just is a lot more complicated when it's bilateral compared to the normal 90% renal cell carcinoma. So genetics and risk factors. So obviously I can tell you working in a cancer center and then even at the cardiologist, like anytime you hear cancer now, I immediately think genetics because one, you're looking further down the line for the lineage, and that's just often a telltale sign of cancer. And then obviously now the more I learn about DNA, RNA, mutations, replication, damage, we learned that that's just a key. I remember one key point that this brings me back to in the semester you talked about. It's like there was a certain age when DNA replication hits it so many times, and then it hits, I believe it's the MET mutation you talked about, and that's the more common one. So obviously a big part of RCC is going to be genetics, meaning that genes control cell growth, cell repair, cell change. So the main gene for RCC is the VHL gene. The VHL gene works, I believe the analogy it gave me was like a brake pedal. It slows down cell growth so cells don't divide too fast, obviously, referring to cancer. So when the VHL gene gets turned off or mutated to the point that it doesn't work and the brakes are gone, then the cells continue to grow at a pace that's abnormal, and this forms the tumors. So bilateral RCC is going to be extremely linked with the hereditary syndromes because it's a lot more rare. So you're not going to find a lot of what's called sporadic cases. I'll kind of talk about those in a second too. So just kind of hitting on the main ones because I believe my screen thing only does 15 minutes. The von Hippel-Lindau disease. So that's the most common one, like we talked about. And then the much more aggressive one is going to be the hereditary leiomyomatosis, RCC. And then so essentially it's just going to be like when a person is born with one of the broken copy of these genes, every kidney cell already has the first hit. Then if another mutation happens later, it's easier for the cancer to start to accumulate, multiply, and then essentially if you have these genes and it's that easy, then both kidneys are going to get it instead of just the one. So just the genetic factor is just a whole new ballgame to be in that rare 1 to 5% of the RCC cases and have bilateral. So RCC in general can tend to be sporadic, like they're high numbers, and these are the risk factors: smoking, obesity, chronic hypertension, long-term dialysis, and then just being male or the ages 50 to 70 when they onset. But bilateral RCC is going to be a lot more closely linked to the genetic risk as well. So pathophysiology, a lot of times, or majority of the time, this is going to occur in the PCT. And kind of when I dug into that, it showed like you're going to see a lot more genetic mutation because there's a lot more mitochondria, like we talked about in all of our classes and multiple of my tests recently. And this allows for more energy, and then often with more energy, you see a lot more of mutation, DNA damage, replication, and just like this is the part of the nephron where a lot of work is going on, and it's exposed to a lot more things. Even if it is where a lot of reabsorption occurs, there's also a lot of toxins filtered from the blood here, and then this can cause damage over time. So essentially the big pathway is VHL to the HIF pathway. So VHL doesn't work, the protein HIF1 alpha builds up. HIF normally tells the body where there isn't enough oxygen, but in cancer is activated all the time when the oxygen is actually normal. Actually, I'll get into that later. Alright, kind of really got into this a lot, but just why it's rare. Don't really see it in both kidneys often. Like I said, RCC is usually sporadic, but when it's hereditary, you have a larger chance of getting it to be bilateral on both sides. Kind of talked about the two different types. Here I took a CT scan. You can kind of see them. It's pretty interesting. I'll kind of get into it in a second, but it was pretty cool looking at the clear cell RCC and how it looks under a microscope, because it just kind of talks about how lots of fat and glycogen inside them, so it appears clear under a microscope, which is really crazy. So diagnoses, obviously the best thing to do is CT with contrast. I don't feel like that's often the first step from what I've noticed in the cases I've seen come about. It's usually a renal ultrasound, and then it kind of goes from there, where they see something that looks like it could be, and then they take the next step. That's usually CT or MRI. And then I kind of noted here, ultrasound useful, but it's really kind of hard to get a good picture of the kidneys to the extent to make that full diagnosis. So then they usually take the next step to be sure. And then, like I said, usually it follows with genetic testing recommended by bilateral, if it's supposed to be bilateral. So let's see. Oh. Clinical effects and systematic impact. So obviously, it kind of mentioned before, RCC is going to affect more than just the kidneys. It can cause the release of hormones and hormone-like substances that cause paraneoplastic syndromes. I believe that's what it was in our notes. Yes. Okay. Noted the main things here. Hypercalcemia. This is caused by the excess of parathyroid related protein. And then we got polycythemia, too many red blood cells, because the tumor makes excess of the factor to create red blood cells. And then hypertension from too much renin production. So if both kidneys are damaged, then the kidney function obviously is going to be decreased, and this obviously would lead to a fluid excess, because we're not filtering out things and reabsorbing things, and this would, with that, cause an electrolyte imbalance, and this would also disrupt the RAS system, which I noted here below. So treatment. This is where I get kind of lost. I mean, I just got kind of, it just seems so complicated. The main treatment it noted was partial nephrectomy, meaning that only the tumor part of the kidney is removed, which obviously is best case. They can get in there and take that part out. A full nephrectomy is only done if the tumor is very large and very aggressive. Obviously, that's worst case, and I would assume that they wouldn't do that unless they really believe it's going to metastasize, or the other one can be partial, or the other one can be salvaged. And then obviously there's medications that they use to kind of step in as that inhibitor, to kind of regulate that factor. They can do, I believe I read that they can do, the radiofrequency ablations for the small tumors, and then a cryoablation for small tumors as well. Also, I believe, I'd have to go double check, but I believe with the hereditary tumors, there is a stronger correlation that those grow slower. And with that, sometimes they'll hold off on these more aggressive treatments and kind of just watch that and see if they can make sure it doesn't grow at the fastest pace. I'll speed up a little bit. Melanoma tumors require long-term monitoring, as I was just mentioning.